Bristol Community College, Mathematics with Dan Avedikian, Math 119, Fundamental Statistics, Section 7.1, Problem 8. This is Section 7.1, Problem number 8. It says the amount of time that it takes Linda to get from her house to BCC is uniformly distributed between 30 and 50 minutes. So part A is draw the graph. So because the question says uniformly, the graph will be some type of rectangle. All uniform probability, the graph is a rectangle. So it says the amount of time is uniformly distributed between 30 and 50 minutes. So uniform means it's going to be a rectangle between 30 and 50. To finish the graph, I need to know the height, though. So the total area of the rectangle has to be 1. So from 30 to 50, that amount is 20, right? 30 plus 20 adds up to 50. So if the base is 20 and it multiplies to 1, well, then the height has to be 1 over 20. 20 times 1 over 20 is 20 over 20, which reduces to 1. So part A, draw the graph. There's the graph. You don't have to have the 20 in the middle here, but just it goes from 30 to 50 along the base, and the height is 1 over 20. So now B, what is the probability that it takes Linda more than 45 minutes to get to school? So more than 45. So we have a rectangle that goes from 30 to 50. The height is 1 over 20. So from 30 to 50, 40 would be in the middle. 45 is that last little bit of the rectangle. So more than 45, that's the stuff that comes after it. So from 45 to 50, the length or base would be 5, and the height is 1 over 20. So base times height, the base is 5, times the height is 1 over 20. So you can multiply it as a fraction. Think of the 5 as 5 over 1. So top times top, 5 times 1 is 5. Base times base, 1 times 20 is 20. 5 over 20 I can see as a fourth, which I can reduce to 0.25. So the probability that Linda is more than 45 minutes late is a 25% probability. Now, C, what is the probability that it takes Linda less than 40 minutes to get to school? So again, you're going to have that same basic rectangle graph that goes from 30 to 50. The height is 1 over 20. So 40 is right in between 30 and 50. So less than 40 minutes. So less than 40, you would be talking about the left half of that rectangle. So from 30 to 40, the base is 10. So when I do base times height, the base is 10 times the height is 1 over 20. And if you multiply that, it's 10 over 20, or 0.5. So what's the probability that takes Linda less than 40 minutes to get to school? Is 0.5 or 0.50 or 50%. Let's call it 50%. It's a 50% probability that it would take her less than 40 minutes to get to school. And finally, part D, what is the probability that it takes Linda between 40 and 45 minutes to get to school? So again, you can have that same rectangle graph. One end is 30, one end is 50. The height is 1 over 20. So between 40 and 45 minutes would be that part of the rectangle. So the base of that area from 40 to 45 is a base of 5. So again, the area is base times height. The base is 5 times the height is 1 over 120 for all of them. So you multiply 5 times 1 over 20. You get 5 over 20, which again I can see will reduce to 1/4 or 0.25. So what's the probability that it will take between 40 and 45 minutes to get to school? 0.25, or a 25% probability.